In your textbook, there is a question which says question number 22 on page number 17. Okay, so question number 22 on page 17 actually is asking you two questions on balancing chemical equations by the partial equation method. I will do the first question, the first bit of question 22. I want you to do the second one on your own. All right. So the first bit is reaction of excess ammonia, okay, with chlorine. And here they have also mentioned that ammonia is a reducing agent here. The question is there in the textbook, so all of you can refer to it. Like I said before, the question will always tell you what the steps are. The first step that they have described is that ammonia first reacts with chlorine to give hydrogen chloride. Okay, and also hydrogen chloride and nitrogen. So let's first write down the reaction for the first step. Okay, so they are saying that ammonia. So for such questions, it's very important that you know what the chemical formulae are. Okay, so ammonia is reacting with chlorine to give hydrogen chloride plus nitrogen gas. Alright, that is the first equation for the step A. The second step that they have mentioned is hydrogen chloride, which is produced in the previous step, further reacts with excess ammonia okay, to give ammonium chloride. Okay, so this is the second step that they have mentioned. So let's write down the equation. So hydrogen chloride reacts with excess ammonia. So there is extra ammonia present in the reaction, and it reacts with hydrogen chloride to give ammonium chloride. Okay, so these are the two reactions that you have to keep in your mind. So like I said previously, after writing down the equations, you will write the equations one below the other. So step 1 was NH3 plus Cl2 giving HCl plus N2. The second reaction was hydrogen chloride plus ammonia giving ammonium chloride. Okay, so these are the two reactions, and you need to balance this reaction of excess ammonia with chlorine by the partial equation method. So this is the first step. So first step of it. Okay, now look at the equations, both the steps. Check which of the reactions are not balanced. Let's look at the first equation. So we've got one atom of nitrogen here, but whereas there are two atoms of nitrogen on the product. So I will go ahead and write a 2 in front of ammonia. By doing that, I have increased the number of nitrogen atoms, made it equal to the number of nitrogen atoms in the product. Also, I have increased the number of hydrogen atoms. So now the hydrogen atoms on the reactant is 2 into 3, which is 6. But on the right hand side, we have only one atom of hydrogen, right? So what I'll do is I'll write a 6 in front of HCl. So now hydrogen atoms would be balanced on either side. Because I wrote a 6 here, the number of chlorine atoms has also increased to 6. On the left hand side, chlorine atoms are only 2 in number, so I will balance this by writing a 3 in front of chlorine. So now if you look at the equation, it seems to be balanced. Let's go ahead and look at the second equation. Is that balanced? So we've got 1 atom of nitrogen, we've got 3 plus 1, 4 atoms of hydrogen and 1 atom of chlorine. So both the reactions are right now balanced. There is a common molecule in the reactant and the product, which is hydrogen chloride. However, the number of hydrogen chloride molecules are not the same. To cancel them out effectively, I will multiply the second equation by 6. On doing that, what happens is I'm increasing the molecules in the second equation by 6. So it becomes 6 HCl, 6 ammonia, molecules of ammonia, and 6 molecules of ammonium chloride. So after making sure that the common molecules can be effectively cancelled out, I will write, okay, another molecule which seems to be common in step 1 and step 2 are number of molecules of ammonia. However, both the molecules of ammonia are on the same side, which is the reactant side. So instead of cancelling them out, they would be written by adding the number of molecules together. So if I write ammonia and add the number of molecules of ammonia, I've got 6 plus 2, which is 8 molecules of ammonia plus, okay, let's cancel them out first. I forgot that step. So the common molecules are cancelled out. I have 8 molecules of ammonia and I have 3 molecules of chlorine forming 6 molecules of ammonium chloride plus also releasing nitrogen gas. So now if you look at the final equation here, all the numbers, okay, or the numbers in front of the compound, they are called stoichiometry coefficients. Okay, they are called stoichiometry, CHI, stoichiometry, or stoichiometric, IC, coefficient. Okay, these numbers are actually called stoichiometric coefficients. All the numbers are very unique. They cannot be simplified any further. So this will be the final equation for reaction of excess ammonia using reaction of excess ammonia with chlorine. Alright, if you want, you can check the number of atoms. I've got 8 nitrogen on the reactant side. On the product side, I have 6 plus 2, 8 number of nitrogen atoms. Hydrogen is 8 into 3, 24. However, on the right hand side, I've got 6 into 4, 24. And we have 3 into 2, 6 chlorine atoms. I have got 6 chlorine atoms again. So the equation is a balanced chemical equation. Alright.